My name is Evan Elias. I'm an engineering director at Tumblr. My topic today is automatic MySQL schema management with a tool that I've been developing called Skeema. Before I get into what Skeema is, let me first just define what I mean by schema management. By this I mean any system that allows you to organize your table definitions and execute actual DDL, not just alter tables, but also creating tables, dropping tables, the full table lifecycle. So this is different than the notion of a specific OSC tool. So this is kind of like a level above that to allow you to manage your schema changes, creating new tables, dropping old tables, and so forth. So other examples of tools in this space, there's a few software as a service solutions like Flyway and Liquidbase. There are open source tools such as Shift by Square. And then there's migration tools built into MVC frameworks like Rails and Django. But none of these were actually the main inspiration for Skeema. Really, the main inspiration was an internal tool that Facebook has called AOSC. If any of you were at Percona Live in Europe this past year, I believe there was a talk on it. Basically, AOSC is this great magical tool that allows any engineer at Facebook to make a schema change just by doing a pull request, essentially, on a schema repo. And it allows people with very little or no MySQL experience to create tables and change tables in a self-service manner. When I left Facebook a couple years ago, I joined a startup for a little while, building a new social network, and quickly discovered that there was no good open source tool that lets you manage schemas in this manner. So that kind of gave me the idea that it's something that there's definitely an opportunity for a new open source tool to fill. So Skeema itself is a command line tool. It's not a hosted solution. There's no web-based environment for it yet. That is a direction I might go in the future. But for now, it's just command line. It's designed specifically for MySQL, as well as Percona Server and MariaDB. But basically, it's geared towards several MySQL isms, where like if you're familiar with how to configure and use MySQL, it should be pretty easy to use Skeema. It's currently geared specifically for InnoDB, but in the future I would like to add support for other storage engines. It's free and open source, an Apache license. You can go on GitHub and download it, build it. It's written in Go, so you get static binaries for Linux or Mac OS. I haven't put binaries up to download yet. I'm going to be doing that very soon, though. But if you have the Go toolchain, it's very easy to compile any Go program. So in terms of where this fits in the MySQL ecosystem, it's sort of a combination of a few different types of tools conceptually. One is the notion of a schema dumper. This is something I've seen at many companies, often written from scratch. It's the idea of some kind of tool that iterates over your tables and spits out files that store the create table statements. Sometimes this is as simple as a call to MySQL dump, because you can supply options that say, just give me the create table statements. That gives them to you in a single file. Other companies have done more complex things to just give you separate files for every table. Out of curiosity, how many of you are at companies that have some sort of tooling to do this? Okay, yeah, it's a good portion. So Skeema does all of that for you, but it also does a bunch of other things. So the second conceptual component is the notion of being able to diff schemas. So that's the ability to compare create table statements across different versions of a table. And there's a few different open source tools that can do this in the MySQL ecosystem. One of them is built by Oracle and comes with the MySQL utilities. Strangely, though, I don't see these tools used that often because on their own, they're not necessarily as useful as they could be. But I think tying them with other functionality makes them a lot more powerful. So the third component here is the notion of automation for executing DDL and OSC. So this is not the actual OSC method, like this is not replacing pt-OSC, but rather it's a layer on top of it to execute PTOSC or any other online schema change tool across an environment that might include many shards where you need to run the same schema change in multiple places. And also managing the full life cycle, so managing create tables and drop tables as well. And OSC tools like PTOSC are wonderful tools, but they have a lot of flags. So many people who use PTOSC tend to at least have some scripting around it so that you don't have to remember all the different flags to supply each time. So Skeema as a tool handles that as well as figuring out like which MySQL instances to run a given schema change against. So some of the main design principles behind this tool, because it differs a bit from those other publicly available schema management platforms. The first one is the concept of managing schemas like code. There's a broader trend in the industry of managing infrastructure like code. There's a lot of advantages to being able to do that. You can basically have a Git repo that maintains your whole history of your infrastructure if you can manage it like code. It's also reproducible across multiple environments. Like if you can capture your environment in a set of files, then you can play that back in other environments easily. So there aren't, I'm not really familiar with any other tools that let you do this specifically for MySQL schemas. So that was part of the motivation here. It allows you to easily create a repository or a directory structure where the very top level is a directory that has a subdirectory for every pool or cluster. If you are in a smaller environment with just one database cluster, then you can also skip this level. And then from there, you have a subdirectory. So you have a subdirectory for each pool or cluster. Then within that, you have another subdirectory for each database schema within that cluster. In many cases, this would just be one directory, and you can combine things depending on your environment, whether you have multi-tenancy occurring on multiple levels. But at the very bottom level in the leaf directories, you have one file for each table containing a create table statement. And in Skeema, you can put config files at any level of this directory structure, and they cascade. So you can override settings just for a particular cluster. You can have global settings at the top level that then get overridden by more specific things. If you've ever worked with Apache htaccess files, it's a very similar concept in terms of how things stack between subdirectories. The main point of this is it gives you declarative schema management. So the files containing create table statements are defining what is the ideal state that you want your tables to be in. And then the tool can automatically figure out how to reach that state. So this means you do not need to create migrations by hand. You do not need to write alter tables by hand. That can be kind of scary the first time that you work in a system like this. But everyone I know who has worked in this environment, like in Facebook using their internal thing, like it's very hard to go back to the way of manually writing migrations. And the declarative approach tends to be very familiar to DBAs and database people just because the SQL language itself is declarative. When you write a query, you are defining what data you want and what order you want it in, but you are not defining how to do that. The database knows how to do that. So it's a similar concept here applied to schema management. So with this declarative setup, there are several advantages to this. The biggest one is in a sharded environment. If you are running schema changes across multiple shards, sometimes those will fail. Sometimes you'll have a promotion occur where a master fails, you need to promote a new thing. And you may no longer have the latest version of a table on all of your shards. With a declarative solution, this is really easy to spot what is behind and also apply the changes again. Basically, with a declarative tool, you can just keep running it in a loop if you want, and it'll be a no-op on any place where the alter has already been applied. So with a declarative solution, you don't need to write alter tables. You don't need to look at the manual to figure out how to do some particularly unusual alter table. You don't need to write any code in Ruby or Python to manage migrations and manually define the up and down versions of how to roll something back. You definitely do not need to do any XML. So that's kind of in reference to Liquid Base, which supports things other than XML as well. But like, you know, I would die happy if I never have to write or read any XML ever again for the rest of my life. So it's basically your repository is create tables all the way down. So in Git or any arbitrary SCM tool, you manage the versioning of these files that contain create table statements. And then Skeema can figure out how to convert that into a set of alter table, create table, drop table statements. And you can basically diff against any arbitrary version in the history of the repo against live databases and figure out basically how to convert the live database into the state in the file system that you want. Another main design principle is that it's very, very agnostic. So when you're building tooling in the MySQL world, it's tricky these days because there's so many different ways to do things. There's different ways to shard. There's different tools to do schema changes. You know, there's many companies use Git, but some use Mercurial or Subversion or other tools in terms of SCM. Different languages are in use. So the design of Skeema, it purposely allows you to integrate with many different things, and it's not opinionated about these choices. In some cases, that means the configuration just supports arbitrary command lines where you can plug in an external tool of your choice. Another main principle is that it supports multiple environments. So in the configuration for the tool, you can define any number of arbitrary environments, giving them any name you want. Some common examples would be dev, test, staging, prod. But really, you can set this up however you want. This also fits in with the declarative nature of being able to apply the state of the create table statements in the file system to any arbitrary database or environment. So you can migrate one environment at a time. You can see visibility into like whether a given change has actually been applied to an environment. And it's a flexible configuration that supports patterns from having a central staging or test or dev, or you can do a pattern where every engineer has their own dev database on localhost. It'll support either of those setups. Besides that, the configuration is just flexible in general. As I mentioned, you can override things in subdirectories, which essentially gives you the ability to define different settings per environment, per cluster, or per database schema. There are also a few options that let you do things conditionally based on table sizes. So you might do one approach for schema changes to a large table and a totally different approach to a smaller table. So one example is if you want to define a config where you use pt-osc for any table that is a gig or larger, but use MySQL 5.6's built-in online DDL for smaller tables, you can do that. I'll go into what the specific config options here mean later in the talk. But the main reason for supporting this is that I don't know how many of you have used the built-in algorithm equals online or lock equals none support in MySQL 5.6 and up. It's really cool they added support for this so that doing an alter no longer blocks writes, but replicating the alter still is a problem that can cause replication lag. So it's common to, if you're using the new support for online DDL that's built in to MySQL, you can't really use it on large tables because you'll get replication lag. But for small tables, it's relatively safe. You might want to configure things so that in development, you just use standard alters, no algorithm equals online, no pt-osc. So in Skeema, you can configure it so that development doesn't use those, but production and staging does. You'll also note if you've ever configured MySQL Server, I'm supporting very similar config semantics in terms of there are config group names, whereas in MySQL, those configure different specific programs. In Skeema, they configure environments. So here we're saying in development, apply these settings. It supports skip prefixes, which just like in the MySQL server, it means disable something or null it out. In this case, it's kind of a convoluted example because the defaults for all of these options are to have them be disabled anyway. But at least with this setup, you could, if you globally configured for all environments that you normally want to use pt-OSC, you could then override that in development by saying skip all of these settings. You can configure things so that there are safety checks for destructive actions, meaning like dropping a table or dropping a column or changing the type of a column in a way that could lose data. So Skeema is aware of what sort of DDL is potentially destructive, and you can configure where safety checks are applied. So you could say, in all environments except for dev, which is what this does, basically it's a config statement that is not inside of any environment group. So this applies to everything. So it's saying, for anything below size 1 byte, allow all unsafe operations. So as a special case, Skeema treats any table with no rows as 0 bytes, even though in reality on the file system it's like 16K or 64K or something like that. But then we're saying in dev, allow unsafe changes always, because it's not production data. You can say for a specific database schema, apply different flags to pt-OSC. Again, a slightly convoluted example, but the main takeaway here is at the top level, we're defining a global config that says to use pt-online-schema-change. But then for some specific cluster and some specific schema in that cluster, we're then having another config file that has basically overrides the alter wrapper setting. And one final example, you can say for a particular database schema on a particular cluster, use different timeouts or use different arbitrary connection parameters. So Skeema has a connection options setting, which just allows you to, for every connection that Skeema makes, apply these extra config settings to the session. And it also has the ability to pass this through as a variable to other command lines so that when you're configuring pt-online-schema-change, you don't have to retype all of this. You can just apply it as a single variable. So that's a broad overview of what the motivations behind this tool were. So here's how you actually use it. So first thing you need to do once you have installed it is get a dump of your create table statements to the file system. And many of the subcommands in Skeema are loosely modeled after Git just in terms of the concepts. But again, you can use Skeema with any source control system. It's a different layer than your actual source control. Many of the commands take an environment name after the command. That's an optional parameter. If you omit it, it defaults to production. It's sort of like how Git defaults to master. The idea there is if you don't have different environments, then it makes sense to have some default. That is the thing that you're operating on. Currently you cannot, but that's something that I'm definitely thinking of adding because there are cases where you would want to. So the way Skeema init works, you point it at a MySQL instance, and then it just iterates over the database schemas and iterates over the tables in each schema and puts them on the file system. And then along the way, it creates those .schema option files, which by default will just contain, at the top level, it'll be the host and port. Then the level below that, it'll be schema names. So in terms of what this actually looks like. So first, the options. If you've ever used the MySQL command line client, this will be very familiar to you. I took great pain to make it match that as closely as possible, down to things like using localhost means use a Unix domain socket, versus 127.0.0.1 means connect over TCP/IP to local. Same thing with a password prompt. If you just supply -p, it will prompt you. If you supply an actual password on the command line, which is terribly insecure, but you can do it. You need to not have a space there. Exactly like using MySQL command line client. If a .my.cnf file exists in your home directory, it will be parsed just for user and password. Any other options in there are ignored. And by default, Skeema init will create a directory named after the host and port, but you probably want to override that to be some arbitrary cluster name. So you can do that with a dir option. So when you run that, it spits out output that shows you basically all the directories and files it's creating. And so it'll iterate over, well, so here we're connecting to a specific fake host name. It's a non-standard port because my examples here were using Docker on my local machine. And here we're calling the directory schemas because it's the assumption that you only have one cluster, so you're not going to name it after a cluster. But if you have multiple clusters, sets of masters and replicas, then you'd probably want to have the directory name reflect the purpose of the cluster. So iterate through that and write out .SQL files. Well, first it's creating subdirectories for every schema that it found on that database. It's smart enough to ignore information schema and the MySQL system schema and performance schema. But for all the actual data schemas, it will create a subdirectory for them and then put .SQL files in each of them. So in this example here, I'm showing these were the databases on my test instance. So there was a schema called analytics and a schema called product. And then you can see it created a directory for each of those. There's a top level .schema file here controlling the host. And then for every table, we get .SQL files. And in terms of what each of these things looks like, so that top level .schema file has the host name and port. Ordinarily, you would need some kind of system to have this follow role changes. So if a master promotion occurs, you would need to make sure this gets updated. There is support for that. I'll get to that a little later. There's a few ways to approach that. You could also have, if you have Chef or Puppet or something, you could also have these files be templated in your config management system and update them that way as well. So this is just the config that goes into these files by default when they're first created, but you can add any other arbitrary config to these files. So in the .schema file in each of the databases, you'll see it just is mapping the schema name. So this is how we map a directory to a schema name. And then each of those .SQL files itself just contains a create table statement. It's literally exactly what MySQL would show you in a show create table. Also kind of in this realm of dumping schemas, there's support for pulling in changes that were made out of band. By that I mean if someone were to run an alter table or create table directly against the database without going through schema for the change. There's a notion of a pull command in schema, so you can say, look at whatever environment I specified. So you could say, look at production and update my local files based on whatever changed out of band in production. So here in this example, I am altering a table just directly in the MySQL client to add a column, and then I'm also creating a new table. So then when I run schema pull, it will see that those things changed. It'll see this new table and create a new file for it, and then it will see that this other existing table now has a new definition. One thing I'll also mention is that the directory that you run schema commands from actually matters. So in this case, I did schema pull from the top of my schemas directory, which means it'll recursively iterate into all the subdirectories. If I were to run schema pull just from this analytics database subdirectory, you would only update that database schema. One other thing that I kind of lump into the realm of schema dumping is the notion of a linter. So there's a schema lint command. It's a little misnamed at this point. It's not really a full linter, but that's the direction that it's going to be developed into. Right now, it just identifies invalid SQL, so like syntax errors, and it also reformats create table statements to match the format that MySQL uses in show create table. But in future versions, I plan on adding warnings for finding redundant indexes, finding tables that don't have primary keys, various configurable behavior to spot bad practices in your tables. And the exit code tells you information so that you know what happened, and you could use this in a pipeline. An exit code of 0 means the linter did not find anything to change and did not find any problems. A 1 means that it reformatted at least one file but did not find any fatal errors. A 2 or more means that there was a syntax error or some other problem connecting to the instance. So an example of what this looks like when reformatting something, here there's just an example, create table statement in a .SQL file. So this is like a user's table in some generic product. So here the format is like non-standard in terms of like the primary key is being defined on the same line as the column. Some things are using backticks, some aren't. So when we run schema lint, it will give you output saying any file that it had to touch. It'll tell you what it did. And then afterwards, it will be in the exact same format as show create table, where the primary key is its own line. Some extra defaults and stuff are specified clearly. Things that are nullable in the right place, it'll show that. Another example in terms of catching invalid SQL. So here I purposely changed this so that instead of saying default, it says default. It's hard to catch by eye, this kind of problem. But if you run schema lint on that, it will show you the exact error that would happen if you tried to run that statement in MySQL. And then it tells you how many syntax errors it found too. All right, moving on to the concept of a schema differ. So similar invocation on the command line. You run schema diff and then an environment. And what that will do is it will tell you, it'll output a series of DDL statements that would convert the current state of whatever environment you pointed it to the state of the file system. So again, the file system is your desired state. And if you actually ran that DDL, it would basically cause the two to be in sync. But schema diff never runs DDL, it just outputs it. So it's usable as a dry run before actually executing schema changes. So to show you what that looks like, let's go back to this example table. Say we want to add a new column and add an index. So we just go in your text editor and add a line for the new column, add a line for the new index, save the file. Then after that, if you run schema diff, it will compare the state of whatever environment you specified. And again, the default is always production. So here it's going to that host that was defined in production, looking at each subdirectory, finding the schema name that directory maps to, looking at the current state of these tables there, comparing that to the file system, and then auto-generating DDL that would convert the database to match the file system. So in this case, it figured out it's an alter table to add a column and add an index. But it doesn't actually run anything. This is usable in pipelines or other automation systems as well. So first of all, the output, it can be a little hard to parse by eye, but it's intentionally using standard out and standard error depending on the purpose. So these info lines with the timestamps, those are log messages intended for humans. Those go to standard error. The actual SQL statements go to standard out. So in theory, you could pipe these, redirect these to different places. And there's also always a comment inserted saying which MySQL instance it's connecting to or it would connect to. That way, if you have some kind of multi-cluster, multi-shard setup, you could, if you just wanted to use the diffs and not use Schema's ability to actually make changes, you could still do that, and you could parse these comments to know which database instance to apply a given set of DDL to. The exit codes, again, are usable in automation. So 0 is no diffs. 1 is there was at least one diff. 2 or more is an error. That matches many diff tools in other areas of Linux. Also, like the standard Linux diff tool, there's a quick option which could be useful in a sharded environment. Like say you have a ton of shards and you want to figure out which shard maybe did not complete a schema change. You could use --quick in schema diff, and that would just change the output to only be a list of hosts and ports of places that have at least one change that needs to be made. And also, if you've configured an external OSC tool like pt-OSC, the output includes that full command line templated out to include all the flags and the full invocation of pt-OSC. So I'll show you an example of that a little later. And finally, there's the notion of actually executing DDL. So the command for this is schema push. It's the exact same behavior as schema diff. It's the same code path for the most part, except instead of just outputting the differences, it actually executes the DDL. And if you've configured an OSC tool, it will actually execute that OSC tool. So the recommended workflow would be to first run schema diff to see what the generated DDL is. Then you can run push to execute it. And then if you're paranoid, you can run diff again just to confirm that there are no differences remaining. So in terms of what this looks like for that same example from before, running schema diff shows that same alter that I showed on a few slides back. But then if I actually run schema push, now instead of saying generating diff, it's saying pushing changes. And in this example, I have not configured an OSC tool, but I'll show examples of that later. So it will go and make this alter and then tell you when it completes. I was just doing this on a Docker instance, which is why the alter took 0 seconds. Ordinarily, alters are not super fast in MySQL if it's a real table with a lot of data. And then afterwards, running diff again, and it's showing no differences found. And again, in this example, I'm running it from the low level, like the lowest level directory, like for the actual product database schema. So it's only looking at changes in that database schema. It's not looking at all of the schemas on the MySQL instance. Or if you had multiple clusters, you could run this from the top level, and it would push all the changes that need to be made across your entire environment. There are safety checks around destructive actions, as I mentioned a little bit earlier. So by default, destructive actions are not allowed. So the way that you would drop a table in a declarative setup would be you delete that corresponding .SQL file. So here, if I delete the .SQL file for some table, and then I try to do push, it will show an error saying that by default, drop table is not allowed. It will still output the DDL that would have been run. It just gets commented out and not actually executed. And then it'll tell you at the end it skipped something due to error. So if you want to actually run that, you can use this allow unsafe option, which just says across the board, allow unsafe operations regardless of table size. And there are other settings you could use, more likely in a config file, to say, by default, allow unsafe operations for small tables or tables without rows. So some of these more advanced configuration options that I've hinted at. One thing is the notion of shell outs, basically arbitrary command lines that you can configure. So currently, Skeema supports these for configuring online schema change tools, and it supports them for configuring service discovery tools. The command line that you can configure will support several placeholder variables so that you can dynamically pass information to the tool that you're shelling out to. So some of these are connection specific, so like host, port, user, password. Those will get, Skeema already figures out for a given directory what MySQL instance or instances it's supposed to connect to, so it can take that information and plug it into the command line that you want to run. Others are specific to DDL operations. So there's a type placeholder, which would get replaced with either create or drop or alter. Clauses is like the body of an alter statement or create table statement. Size would be the size of the table it's operating on if you want to have some kind of extra level of automation or scripting where schema is calling some script that maybe does some extra sanity checking on some information. And these values will automatically be escaped intelligently. So if one of these options has spaces in it, schema knows to like add quotes. If there are already quotes inside of something, it will escape them intelligently in a way that still works on a shell command line. So when configuring online schema changes, there's a few different options you can use. The main one is alter wrapper. So that is a command line that will be run to actually execute schema changes. So any alter table would get plugged into that. So that's where you would configure pt-osc or some other tool. There's also support for another one called DDL wrapper. So whereas alter wrapper just affects alters, DDL wrapper affects all DDL. So if you want everything, including create table and drop table, to go through some common script, you could use DDL wrapper instead. If you want to use MySQL 5.6 and up online DDL instead of an external tool, you can use alter algorithm and alter lock. Those translate directly to the algorithm and lock clauses of an alter table statement. And the main powerful thing here is this alter wrapper min size option. This is what says like only use alter wrapper for tables at or exceeding a minimum size in bytes. And you can combine these. So you could say alter wrapper min size and also apply alter algorithm and alter lock, which gives you a config. This was the same example I had a little while back, where for any table that's a gig or more, we want to use pt-osc. For anything smaller, we want to use built-in DDL. And also in terms of how sizes are specified, same as in MySQL server configs, it supports suffixes of M for megabyte and G for gig, K for kilobyte. So with that config on the previous slide, if you went to run a diff, so in this example, I skipped the slide for brevity, but let's say we're adding one column to one small table and one column to a larger table. So for the larger table with that config on the previous slide, it's basically taking that command line to run pt-online-schema-change specified here, and it's plugging in the right values for the alter clauses, the schema name, the table name, host, port, user. Password X basically passes the password through, but in standard out, it just spits out X's so that you're not putting your passwords on standard out. So with this larger table, it's smart enough to see that it's large enough to meet that 1 gig threshold and run this through pt-osc. It still outputs things in a way that could be piped to the MySQL command line client if you so chose. So \! is the shortcut for doing a shell out. You probably wouldn't actually run a command in this manner, but this way it's always compatible with running. Like basically the standard out of schema can always be piped to the command line client if you so choose. And then for a smaller table, it's just doing an alter directly, but using that algorithm equals in place, lock equals none that were specified in the config here. And the tool is smart enough to know that for smaller tables, for larger tables, not to apply these because they don't make sense to include in the alter given to pt-osc, because then you'd be trying to do online schema change twice. Service discovery and sharding. So this is a little tricky to configure, but basically by default, normally the host option in schema configures a host name or IP address. Or it can be a comma-separated list of them. So like say you just have a small number of shards that you just want to define statically. You could have a comma-separated list in the host field. But with a larger sharded environment, you need some way to basically do lookups to Zookeeper, etcd, your console, some arbitrary store of service discovery. So basically you can write a little wrapper script that, given a key name or some information about the cluster, it returns on standard out a list of hosts or host:/port to connect to. So Schema has a host wrapper option, which if you've configured that, then hosts are no longer interpreted as literal host names. Instead, they're interpreted as cluster names. So as a very contrived example, let's say you have some script that goes and connects to some synchronous key value store like etcd, and you pass it a key, and it looks up what MySQL instances correspond to that key. So in this case, our key space might be start with MySQL, because you typically store more than just database configs in service discovery. But then an environment name, because you are going to have different hosts, presumably, for development versus staging and production. And then finally, the host, which in this case is being used more as like a cluster name. And then this script would return a set of host names and ports, or just IP addresses and ports. They can be new line delimited, comma delimited, tab delimited. As long as it's a consistent delimiter, Schema will figure it out and interpret it as a set of host names. In terms of how the commands interact with shards, so if you're configuring host wrapper, you would set it up so that it returns all shard masters, for example. Like if you want to map one directory to a whole bunch of shards, and all those shards have the same tables, you'd make sure that your host wrapper command line returns all masters in that group of shards. So when you run schema diff or schema push, by default, it applies to all shards, and it will do them in the same order they're returned by your script, one at a time. If you want to do that differently, there's a first only option, which says only diff or only push against the very first shard. So that can be useful for canarying things. And there's also a concurrent instances option if you want to configure concurrency, where you're doing alters against many shards at the same time. The pull command, however, only ever runs against the first shard. It doesn't really make sense to pull from multiple shards, so it just uses the first shard as the source of truth. So some workflows in terms of how you would use this. If you have a setup where every engineer has a dev box and has their own dev MySQL on that dev box, you would configure that just by basically the engineers would run Schema from their dev box and configure it so that in the development environment, the host is localhost, and you're configuring a socket, a Unix domain socket to connect to. And then you'd probably also want to allow unsafe changes and skip normal OSC stuff, but that's optional depending what you want to configure. So with this workflow, if you're an engineer and you need to pull in changes that other engineers on your team made, and you want to apply those schema changes to your local dev instance, first you would do git pull, or the equivalent in Mercurial or Subversion or whatever you're using. Basically, bring your local schema repo up to date. Then you could diff it against your dev MySQL to see what changes would need to be applied. So that's changes that your coworkers made. And then you can push to development, which will apply those changes. Now, if you're using Rails or Django or some other opinionated system that has its own notion of migrations, you can still use that in this model. The idea is that you use the migration system of your MVC framework in development, and then you can use Schema to actually push the production changes converted to basically be online schema changes. So you would run Rails migrate or however you normally apply development changes in your framework. And after doing that, you can pull from development to update your Schema repo file system to map whatever you just did to development. And then you can commit that to Git and then push it out to production using Schema the normal way. In terms of what that workflow looks like for production changes in general, typically like you would make a change in a branch, check out a branch of your Schema repo. It doesn't have to be a separate repo, by the way. Like it sometimes makes sense to store your schemas in the same repo as your application. If the changes to the two of them need to be tied together, you can totally do that. But check out a branch, change the files. If you're adding a table, create a new file, commit that, open a pull request, and review it as normal. Like review it like code. Have your coworkers sanity check that your change makes sense. When you get the thumbs up, merge as master. And then these last three steps are the actually basically running the production schema change. So on some probably centralized ops box, check out master of your schema repo, git pull to bring it up to date. You can run schema diff to preview the DDL that it's going to do, and then schema push to actually execute the changes. So under the hood, the way this tool works, it's actually performing all of these operations in a temporary database. By default, that will be called _schema_temp, but you can configure that. It also drops that database at the end automatically by default, but you can also configure that so it keeps it around. But it doesn't parse SQL. I'm not actually parsing create table statements. All of the introspection is done on information schema. So basically, to see what, to understand the current state of the file system, schema will actually run all of those create table statements in a temporary schema, and then look at information schema to see what columns exist, what indexes exist, and so forth. It also automatically sanity checks any auto-generated DDL. So basically, it will create a shadow copy of the table in that temporary schema, and then test the DDL that it generated, and then confirm the final state of the table matches what is expected. So this way, there's no chance of it generating DDL that does not actually match what it's supposed to do. There are also a number of edge cases that schema does not support yet, like partition tables, newer features like generated columns, stuff like that. Basically, it catches at this stage. It'll say like, oh, this is a table using some feature that is not supported yet. And it will skip those. It'll show output saying that it couldn't alter a table like that. It can still dump them to the file system, so it can create and drop tables that it doesn't support, but it can't alter them. In the course of building this, I split a few things out into separate modules. One of them is Go Tango. There's a trend in Go to insert Go into the name of your thing in some way. So this is a MySQL automation and schema introspection library. Right now, it's much heavier on the schema introspection side, but longer term, I'd like to build this into more of a generic MySQL automation library. And then there's MyBase, which is the support for kind of doing MySQL-like configuration and option parsing. And both of these are open source also. You can see them on GitHub. So future directions for this tool. A big one is more statefulness. So right now, schema is not stateful, which means that if two developers were to run it at the same time, it would try to do the same alter twice, potentially. That will already fail. Like, pt-OSC and other tools are smart enough to see that there's a conflict. But it'd still be nice if it, in addition to testing operations in the temp schema, it would be good if it kept track of what was currently running. Support for renaming things. This is the one downside to declarative solutions. Renames are not, there's no clear way to designate that you're trying to rename something instead of adding and dropping it. So I have a few ideas about how to support this, but they have not been implemented yet. The next one's a big thing, a notion of an agent mode. So that Facebook internal tool that I mentioned earlier, the way that it scales out to a huge environment the size of Facebook's is that it's an agent-based solution where you have a piece of software running on every database host, and that hooks into your version control system. So the idea here would be to support that in schema with direct integration with GitHub's API. And that way, the workflow would be you open a pull request, and some approved person could comment on the pull request saying, like, this change is good to push out, and schema would see that and actually make the change once the pull request was merged. Easier integration with Ghost and FBOSC. So you can kind of make these tools work in schema right now. It's a little painful because the way service discovery and schema works, it's geared towards just returning masters. But with Ghost, you typically want to have a master and a chosen replica that's using row-based replication. So I need to figure out some way to cleanly map that to the service discovery hook. And same thing with FBOSC. FBOSC does not work with replication. You run it against each instance individually. So I would need to have some notion of returning all of the replicas in a cluster. And then just missing features. There's a bunch of things I haven't gotten to yet, like foreign keys, which OSC tools tend to not support that well anyway. Partition tables, InnoDB compression, non-InnoDB storage engines, connecting with SSL, Views and triggers, stored procedures, those three things are currently just ignored, so their presence won't break anything, but Schema will not automatically manage them or spit out files that map to their state. And then like full text indexes, spatial indexes, other new features in MySQL. So we are exactly out of time, but happy to answer any questions individually, or we can, I guess we have a few minutes. We can, yeah.
You did mention creating seed data, and that's one big thing that migration tools tend to want to do is to like load up lookup tables and things like that.
So that's not something that is supported currently. There's no notion of DML statements, but it's certainly something that could be added. Or you could have a broader automation, a custom automation system that uses Schema to operate schema changes, but also does some custom DML loading logic. Yes?
Would it be possible to have something like this schema wrap? So I have the customer would have thousands of the same schema.
So, sorry, thousands of?
Of the same schema. So you have one reference schema and all the other ones are similar.
Yeah, so it supports that. Like the way the sharding setup and service discovery works, like if your service discovery can return many instances on the same
MySQL.
it can be on the same MySQL instance or on several. It supports multi-tenancy in both ways. So, yeah. Yes?
With regard to declarative, while working on those, I found two issues where declarative was just not coming up. So, like, open rename, something that you're unable to do.
Yeah.
And furthermore, look and add and you call by the same name. That's also
Yeah, so there's tricky things with Declarative that, currently renames are not supported at all in Schema. I mean, Facebook's setup doesn't support them well either, from what I remember. The solution there was just don't rename things because that tends to break production anyway. But yeah, it's something that I want to improve. Graham? So the question was, what happens if an alter wrapper fails? So it'll spit out the error. If you're running on multiple shards, depending on the type of error, it'll either halt completely or it'll just continue running on other shards. Yeah, I need to add a notion of a cleanup hook also, because things like PTOSC, typically if they do fail, you might need to do some manual cleanup. So I want to add a way to automate that more cleanly. Thank you. Happy to answer more questions. Just come up.